Yes, I guess we can start.
Okay.
Uh, okay. Yes, participants, we are entering into the second session of the day. For our second session, we are having Arth Patel. He is actually the CEO of Tirex Chargers. Arth Patel is basically a computer science graduate from University of South Wales, UK. Currently, he is leading the software department as a young enthusiastic leader for Tirex Chargers. Tax Chargers is actually a complete, it's actually a company which is providing a complete range of fast and slow electric vehicle chargers for two-wheelers, three-wheelers, four-wheelers, and this commercial vehicles such as passenger buses, trucks, etc. They even provide this chargers which are having voltage range from 3.3 kilowatts to 360 kilowatts for different connectors. The best part is all their products are verified and certified by Automotive Research Authority of India, and some of their clients are, I mean, KSCB Limited. Like I have got information from Sajin Ismail that Kerala State Electricity Board Limited is one of their clients. So let's over to Arth Patel. Let's hear more about Tirex Chargers, their company, their products, and how this Tirex Chargers has been established and what all roles he had played to develop this company into such a big one.
Okay. Thank you so much.
Welcome you, Arth Patel.
Yeah. Thank you so much. Hello, everyone. I'm sorry, I didn't get your name, Mr.
Renu.
Renu. Okay. Yeah. Thank you so much. As Mr. Renu mentioned, that we are one of the OEMs who are working with KSEBL. So with KSEBL, we are in process of about establishing 124 chargers, which 29 charging stations, which comprises of 124 chargers, ranging from 3.3 kilowatt to 150 kilowatt. So they are for two-wheelers, three-wheelers, and cars and electric buses as well. So this KSEBL contract goes about 1 year back when we won the tender, and we have been working ever since for them. Basically, our company started about 4 years ago when we had the vision to expand our line of business, which was previously into manufacturing of industrial gearboxes. So this was a complete industry shift for our company, our promoters, from a mechanical line to an electrical line. So initially, due to lack of infrastructure in-house as well as in Ahmedabad and in India overall for the electronic industry in 2015, they went to China. They had a technical partnership with one of the firms over there who was a leading firm and had supplied chargers to Siemens, ABB, and large names across the world. So our technical tie-up initially involved us to have the complete chargers manufactured by them for us, and we simply installed and provided after-sales support here. Down the line, over a period of 4 years, we have localized a lot of components here. A lot of components are made in India. Some of them are still imported from various countries, but a lot is made in India, and we are very happy to say that we are one of the leading players in the charging manufacturing business. As said by Mr. Renu, all our products are certified by ARAI, whether it is a very small charger for residential purposes or a very heavy bus charger. They have been certified by ARAI, and some of our products have been certified by CE as well. So coming back to the panel, which is regarding residential, commercial, and corporate charging, what we have faced and learned from the overall worldwide industry, this whole EV industry worldwide, is that 99% of the people charge their vehicles in their homes only. Either it's in the residential apartment or their bungalow, or at the workplace. That is the only two places where 99% of charging happens. The rest 1% is for the public spaces. The reason being, if you practically see that the cars in the market in India right now, whether it is Tata Nexon or MG, ZSEV or Hyundai Kona, they all have a range from 200 to 300 kilometers. An average person travels about 50 to 60 kilometers a day you wake up, you go from your home to your workplace, you come back. You either meet some friends or relatives in between, you go to their residencies or their places, you socialize and then come back to home. You don't need to travel more than 100 kilometers in a day. So having 2 to 300 kilometers of range is more than sufficient for 300 days, 360 days out of the 365 days in a year. The 5 days remaining, which are used for intercity traveling, let's say you are going from place A to B, you're traveling from one place to another, which is over a span of 100, 200 kilometers, that is where only the concern of longer range lies. Apart from that, for your daily activities, for your daily livelihood, 200-kilometer range is more than enough. So once you have a vehicle with 2 to 300 kilometers of range, you can simply charge it at your home with a AC charger, or at your workplace with similarly a AC charger as well. So in charging domain, there are basically two types of charger, which I think all of you must note it by now. So there is AC charging and there is DC charging. So AC charging is also popularly known as slow charging, while DC charging is also known as fast or rapid or ultra fast. There are different names going on in the market, but basically DC is fast, AC is slow. So at your home, at your workplace, where you park your car for any time above 5 to 6 hours, AC charging is preferred. The advantages of AC charging are longer battery life, better battery health, as well as good battery efficiency. We have worked with a lot of taxi players in the market, the popular taxi players such as Blue Smart, Triple E Taxi. So initially what they did was they had all DC charging at their hubs. So charging their vehicles every day, fast charging their vehicles every day would drain their batteries very fast. Similar to a phone, just like your mobile phone. If you charge using your rapid charger or fast charger every day, your battery health will eventually be very less, and the phone will be very bad and unfit for everyday usage. So there has to be a AC charging in between. A good thumb rule would be having 2 to 3 AC charging sessions for every single DC charging session you have. Now coming back to the residential and commercial office work charging, as I was saying, AC charging is more than sufficient for your everyday work. So if you charge your vehicle, park your vehicle in the evening at your home, charge it throughout the night. In the morning, you can take it, go to work, come back. So for one day, the battery won't be drained. Second day, you do the same thing, come back, and then you again charge your vehicle with the AC charger, and it can go on. You don't need DC charging at all for your everyday work. That is the reason that the companies establishing DC charging stations are primarily focusing on highway places. So intercity travels is where DC charging happens. So if you're going from, let's say, Delhi to Agra, and you need a place in between which supports DC charging, because that is a distance which is more than 200, 250 kilometers. So you leave anywhere, anytime from Delhi, you stay in between, spend half an hour to 1 hour at some place, at some cafe, charge your car with DC charger, which is basically fast charger. So it will charge from 0 to 80% in anything from half an hour to 1 hour. And then you leave for Agra. So that is the only place DC charging is required. Even the government right now, even KSEBL, what they are doing is they are having DC chargers at places which are situated on highways only. In the city, KSEBL is also preferring to have more AC chargers than DC chargers, because they know that the people would spend more time over there and won't require anything which is fast charging. So that is how the whole ecosystem of charging works. Now coming to the capacity of chargers. So AC chargers are usually from 3.3 kilowatt. So essentially a 3.3 kilowatt charger is your everyday plug. The same plug in which, the same socket in which you plug your mobile chargers, your laptop chargers, is the same as 3.3 kilowatt. So that is the same thing as having a 3.3 kilowatt charger in the house. Then it goes on to 7, 11, 15, 22, and it goes on up to 42 kilowatt as well. But it remains a slow charging process. Now, how much charging capacity do you need depends on your car rather than your charger. So there are some cars in the market who support very less amount of charging, no matter how much power you give them. For example, the Tata Tigor electric vehicle, if you plug in a 22 kilowatt AC charger into it, it will still take 3.3 kilowatt because the capacity of the onboard converter is not more than 3.3 kilowatt. That is the reason you should prefer charging uh, with your as in sorry that is the reason you should go for chargers which are supported by your car rather than getting into the whole bubble of fast charging and getting more expensive chargers. Every single car comes with their own onboard charger. They give you a charger with your car which is essentially about 3.3 kilowatts of capacity. So the Tata Tigor is more than sufficient for that charger. If you have a Nexon, an MG or Hyundai, your car can support 7 kilowatt of charging. If you have even more expensive cars such as a Mercedes or a Jaguar, they support 11, 14 and 22 kilowatt charging as well. So charger is only a slave in terms of supply. What the car requires is only given by the charger, no matter what is the capacity of the charger. In simple language, this is like filling up a water tank. No matter how large the water tank is, if the input in the water tank is small, it doesn't matter if you open up a full dam and supply it with the full power of a dam. It will still fill with the small input it has. Same way it works for cars and for chargers as well. Even in DC charging, the car asks for power. So every single message, when you plug your connector into a car, there is a constant communication going between car and the charger. They practically talk with each other. The car requests that, hey charger, give me this much energy. So charger will deliver that much energy. If the battery of the car gets starting to heat up, if the battery of the car is in low power mode or has less health left, then the car will request for less current. So the charger will give less current. So at the end of the day, everything comes down to the car, not the charger. The charger will only give the car whatever the car asks for. It is the same for AC charging and it is the same for DC charging as well. So now my session was basically on the part of residential, commercial and corporate charging parts. So in India for the last 2 years, what we have seen is in the residential and the commercial parts, people prefer to have either 3.3 or 7 kilowatt of charger, not more than that. The reason being, if you are an existing society, if you are a existing residential colony, you already have some power allocated to you, which is 100 kVA or 200 kVA, depending on the size of your society. And it is already being utilized in everyday activities. Every single household is using some energy, and that power is being utilized already. So if you install more capacity of charger at your residential place or your apartment colony or something like that, what will happen is you will have more billing you will consume more energy than what is allocated to you by your discom. For example, KSEBL in your situation. So you will have more usage and then they will charge you more for that. So people prefer to have smaller and lower capacity of chargers at existing colonies and existing workplaces. At new developments where builders are creating new societies or something new construction is going on, what they do is that from day one, they initially apply for a larger load and they have higher capacity of chargers there. So we have some clients in Bangalore who have installed about 22 kilowatt chargers. So that is about 440 kilowatt of power just for the charging part. Sometimes large colonies have 440 kilowatt of power allocated to them for the entire society, for everyday usage, for your lights, your TV, everything. But they have just given it to the charging part because they are a new society. So they took the load accordingly. Old societies cannot do that. That is the reason they prefer smaller capacity and lower capacity of chargers. on road at commercial places, people have like at roadside cafes, at restaurants, on malls. There also at existing places, people are not preferring more than 7 or 22 kilowatt of power. The same reason, the same obstruction comes, which is applicable for the societies as well. They don't have that much power to deliver to a car. That is why they prefer to have lower capacity of chargers. The higher capacity of chargers, which you must have seen in the market, the 60 kilowatt
Hello,
or
sir.
20.
You are not sharing any screen?
No, I'm not sharing any screen. Do you
Okay.
want me to share a screen? I'll share something if you want.
No, no, no. I was just asking because I think is any technical issue.
Now, okay. Is my screen visible?
No, just a moment.
It should be visible now.
Yes, it's visible now. It's visible.
Yeah. Okay. So I'll. So basically, I was talking about, as if you can see on the left side of the screen, that is a small AC charger. It is basically the size of a water bottle. If you stack two water bottles beside each other, it will be roughly the size of an AC charger. And it is, since it is small, it is easy to operate. That is why a lot of companies and a lot of people are preferring to have AC chargers in their market. There is a company called ChargeMod. It is very popular in Kerala, and they manufacture their 7 kilowatt small chargers, and they are doing very well in terms of AC charger market. The other chargers, practically this larger chargers, which are the size of a fridge, this 30 kilowatt one, 60 kilowatt one, 360 kilowatt one, they are mostly for the charging of buses. No car uses those chargers, and they are only used at bus depots. So Ashok Leyland, Tata Motors, JBM, there are some companies who are working with us and other players for their charging. So they operate electric buses throughout the cities. So these chargers are used for those places only. I'll show you a video, if that's okay, where you'll be able to see the charging of bus happening. So if you see here, this is basically a charger the size of a large fridge. It can charge a bus in about 3 to 4 hours. This is the same charger which was being used to charge the bus. So right now, as I was explaining, the same charger is being used to charge the bus as well as the car. But what's happening practically is that if the bus is, since the bus is a larger vehicle, it asks for more energy. So the charger gives more energy to the bus. The car being a smaller vehicle, it asks for less energy. So the charger delivers less energy to the car. So it's all dependent on the vehicle rather than the charger to provide the energy. So this is something also known as a combo charger. So basically a combo charger is something which has, sorry. If you see here, you can see 1, 2 and 3 types of different adapters for 3 different vehicles. So every car has their own prototype, which is either one of these or there is a one more prototype. So each of those vehicles follow one or more of this prototype. This is similar to having your own phone charger. So iPhone has a different pin, Android phones has a different connector. Same way, cars have a different connector depending on the model. But worldwide, this middle one, which is also known as CCS, is a common is a common protocol which is accepted worldwide, and most of the cars support this type of charging. So this combo charger can be used to charge 3 different vehicles at the same time, having 3 different connectors as well. So if you see here, as I was saying, this is also commercial charging. So for taxi vehicles and taxi players, they have their own charging stations installed at their charging spaces. So what they do is they have their own charging stations. So they go there and then charge free of cost and then operate. This reduces their operating cost as well as this reduces their operating cost, and they don't have to wait in line. So that is the reason a lot of commercial charging in India is being right now utilized by taxi players only. Because as I said, private players, private people such as you and me charge their vehicles inside their homes or workplace only. They don't charge at their malls or any other places. So the commercial market in India right now is being completely utilized by taxi players. So that was it from my end. If you have any questions, let me know. I can answer your queries and questions or doubts if you have any. Is there a question Q&A session?
Yes.
Yes, sir.
Yeah, definitely. So please go ahead and ask questions if you want.
Sir, I am also designing one charger.
Okay.
Actually from some basically one IEEE paper I got 3 kilowatt and above chargers.
Hmm.
1 kilowatt chargers are very, I want to design for 1 kilowatt. My application basically I am thinking of a bicycle or like that. That is my part.
Hmm.
But when I am doing that simulation and hardware comparison, the
Hmm.
values are coming different, sir, because the filter means while doing the hardware part, the filters are not used after the rectification and all, because it's directly used at the load side
Hmm.
when I have done the hardware. But when simulation in MATLAB, if I take that value of filter here, then the
Hmm.
voltages and these are not matching, sir.
Okay. So this is more of a technical question. If you
Hmm.
want, you can just drop me an email. I'll connect you with the technical person in our company who looks over the whole R&D and everything. His
Okay,
name,
sir.
his name is Faisal. And
Hmm.
just drop me an email. I'm sure Mr. Renu can share my email with you, and I will connect you with him, and he can help you with the whole MATLAB simulation and everything.
Okay, sir. Okay. Thank you, sir.
Does anyone have any more questions as well?
Arth Patel, do you own a electric car?
Yes, I do own a Hyundai Kona.
Oh, you own a Hyundai Kona.
Yes, yes.
Okay. So my query to you is, how often you use AC charger and how often you use DC charger?
So to be honest, the only one time, so I live in Ahmedabad. So my company is based in Ahmedabad only. So the only one time I have owned Hyundai Kona for last 2 years. I was one
Okay.
of the first people in Ahmedabad to have an electric car. So the only single time, or for the past 2 years, the only one time I have used DC charging is when I have went from Ahmedabad to Baroda. So Baroda is an adjoining city beside Ahmedabad. It is about 150 kilometers away. So that is the only day in the last 2 years which I have used DC charging.
Okay.
Apart from that, I have used AC charging every 2 to 3 days at my residence. As I said, so This office is about 30 kilometers away from my residence. So every day I have to travel at least 60 kilometers from my home to office and the office to back to home. So on an average, my car gives me a range of about 300 kilometers. So for about 4 to 5 days, my battery lasts. And after, at the fourth or fifth day, I use my home's AC charger and then charge my vehicle overnight. And the next, in the morning, I'm ready to go again for 4 to 5 days. So practically, as I said before, a private person or a private car owner will rarely use DC charging for his vehicle. Only and only if he's traveling intercity or if he has an urgent need to fill up his battery. He will be more than happy using his AC charging.
Okay. My next question is in Gujarat,
Yes.
in your state, you might have had several charging stations which has been established from your end.
Yes.
Okay, is it completely owned and run by you people only, or you have given it as for some other distribution, something like that?
Okay, so there are different models our company works in. So like KSEBL, so KSEBL is the Discom of Kerala. So same way we have a Discom in Gujarat. So if you ask about the stations owned by the KSEBL, we just supply the equipment to them and they own the charging station. There is also a model in which we work in is the hybrid owned model. So if someone wants to open a charging station but doesn't want to put in a lot of money, so what we do is we do 50% investment from company side and 50% investment from the person who wants to open their charging station, and we share the revenue accordingly. So a lot of different models our company works in. Some are completely owned by other people. We just provide the equipment, like in case of KSEBL. Some are hybrid owned, partially by the company and partially by the owner, and we share the revenue. At some places, the company owns charging stations, like 100% the charging stations are owned by us.
Okay.
So
how you managing the 100% on the company charging station? Do you get a continuous rush over there? You people are able to manage, like, even though if you are using DC charging there, it will take around half an hour to get it completely charged, right?
yes.
So, I don't know how is the EV revolution in your state now, in Gujarat now. So, is your charging stations are having some management issues? Management issues in the sense public management, like one car is coming, or Sajin has actually shown us on app Electrify, or you people are using that such sort of apps for managing this, like a person who is driving to your charging station can do the reservation for a time slot for charging before he is arriving there, like that. You are using any such sort of applications?
Yes, we are using. So there is a company called iCharge, which has been a partner with us throughout our journey for the last 4 years. So they provide us the application which manages. I'll share my screen again and show you some screenshots of the application, which you will be more clearer how.
And we also wish to see some of the videos of your 100% company owned charging stations, if you have any videos.
Were you able to see the video which I showed on YouTube?
I didn't get you.
Were you able to see the video?
Yeah, we are able to see it very clearly.
Okay, sure. I will. I don't have any videos of 100% owned charging stations by our company, but I will share some images with you after the session, which you can circulate to the people. I'll ask my team to have some. So
another question which I wish to ask you is, before you have shown a Tata Nexon car is getting charged in I think that was a residential area.
No, that in the video where Tata Nexon was getting charged, it was below a office area. It was not
below your office area. Okay, fine. Is there any public place where you have kept these chargers like a single module so that the people can come and use it by themselves, just like the gas stations in foreign countries?
Yes, we have. So basically, what we have done for that is there are some food courts on highways. We have tied up with them, and we have placed our charging station at one or two places where the people can come charge their car, and while they charge, since it will take 30 minutes to 1 hour to charge their vehicle, they come charge their car and enjoy the beverages and foods at those cafes, and then drive away. We have done that in the past.
Sir,
So
one question.
yes.
Sir, which part research is needed in this charging? Because now whatever you are saying that okay, everything is set. So as a researcher, if we have to concentrate for the charging station or chargers design or some, so what are the drawbacks or limitations which we have to means we can remove that as a researcher?
So from what we have faced in the past 4 years, India is very good in terms of IT and software. The charger, even though it is an electrical thing, it has an internal firmware which it runs on. It is made on C language, if you are familiar with the C language. There is an embedded software which communicates the internal components of the charger. So my suggestion and my advice would be to focus on research in the embedded language, as in research to have a better and better firmware which can deliver the things more efficiently using the same components. So this is similar to having, let's say, there is an iPhone on one end and there is a Samsung phone on the other end. If you look at the electrical parts, electrical components, they will all have their resistors, they will have a LED display and everything. But there is a very different feel and efficiency and better usage in terms and advantages of one over the other. Am I right?
Yes, sir.
Yeah, so that is the whole magic of having a good firmware which is more efficient, which is better in operation, which is more user friendly. So my suggestion would be to focus on research in that direction only, because anyway the electrical components are same in one charger or the other. They all have 80 to 90% components are same. They are resistors, they are microprocessors, and the same things which everyone has in an electrical
Yes, sir.
electrical charger or any other electrical unit. What differentiates a product from another is the firmware. So focus on the firmware and or for the research part.
Okay, sir. Okay, thank you. Thank you.
Arth Patel, one of the participants has asked that can you tell the price range for different chargers?
Yeah, definitely. So the AC charger, since they are for end user application, they are supposed to be purchased by an individual. So they start from anywhere from 5 to 6,000 rupees and go up to 1 lakh rupees. So the 3.3 kilowatt charger has a price of 5 to 6,000, and it 22 kilowatt, depending on what the has it. If it has a touch screen, the price increases. If it doesn't have a touch screen, the price decreases. So from anywhere from 5 to 6,000 rupees, it can go up to 1 lakh for AC chargers. For DC chargers, the price starts at about 3 to 4 lakh rupees and goes up to 40-50 lakhs. The 40-50 lakh chargers are usually used in buses and heavy electric trucks.
Okay.
Sir, I have a doubt. Hello.
Yeah.
So you mentioned about 3.3 kilowatt hour battery, and I have my doubt is Data Nexon is having 30.2 kilowatt hour battery. So when it is connected to a 3.3 kW charger, how much time will it take to get full charge? What determines the time of full charging? Whether it is depending on the battery or it is on the charger?
No. The time of charging is always dependent on the battery, because for cars it is dependent on the battery. For anything from 3-wheelers, 2-wheelers or cycles, it is dependent on the charger. Because what happens is that cars and other larger vehicles such as bus has something called a BMS, which is the battery management system. So the battery management system monitors the health, the temperature of the battery in the vehicle and everything, and accordingly asks for power from the car or charger. So if the temperature of the battery rises up, if there is a lot of heat around the vehicle, the BMS will ask for less power and it will take longer time to charge. If the battery is in good health, that environment is not very hot around the vehicle, it will ask for more power and the car will get charged faster. For 2 and 3 wheelers, having BMS increases the cost of the vehicle very significantly. That is why for 2 and 3 wheelers, there is no such thing as BMS. So for 2 and 3 wheelers, a simple formula to know how much time it will take is divide the capacity of the battery by the power you are supplying. So if, as you said, if the battery is about 30 kilowatt hours and you are giving 3 kilowatt of charger, then it will take around 10 hours to get charged. 30 divided by 3. That is a simple formula for 2 and 3 wheelers. For 4 wheelers, it can vary depending on the BMS of the car or the bus or anything.
Sir, one more doubt. Is the charging is constant voltage charging in cars?
No. For cars, up to 0 to 80%, usually the voltage is constant unless something bad happens, such as the battery temperature rises up. On an ideal condition, 0 to 80% is usually constant voltage, which is constant throughout the process. After 80%,
and the voltage is determined by the battery specification, right?
Yeah, the battery's voltage, for which it demands from the charger.
Okay.
And after 80%, the battery starts asking for less voltage and the current slowly declines. Just like your phone. So 0 to 80% is usually done very fast. And then after 80%, the demand decreases and it's like a slope of less demand. It goes from higher to lower.
All determined by the BMS, right?
Yes, all determined by the BMS of the battery.
So for 2 wheelers, it is not like that. It is always constant.
For 2 and 3 wheelers, there is no BMS present. So it is all depending on the charger and the vehicle's battery. Because if you enable BMS in 2 and 3 wheelers, it will be very expensive.
So will it be constant voltage charging or what determines?
Yeah, for 2 and 3 wheelers, it is mostly constant voltage charging.
Okay, thank you.
A minor fluctuation is there, but the voltage stays constant.
Okay.
Sir, good afternoon. Sir, I just want to ask you some general question related to EV. Like some EV kits are available for bicycle and for two-wheelers online. So is it good to purchase and convert your general bicycle into a EV bicycle?
But I have read about them and articles about them. They are doing very good. So rather than going and spending more money to buy a new electric bicycle, I would prefer if people would start doing retrofitting. Convert your existing two-wheeler to an electric vehicle. It is very good and it has been proven very efficient as well. But again, same thing here. You have to look for the company you are going with, because a lot of companies simply buys off the kits from China and Taiwan and they just supply and there is no after service support given. So if it's a larger company and more established one and they have a good after sales service support, then you can definitely go on and buy the kit and do the retrofitting.
Okay, sir. So one more question. Generally, which one is more economical, like DC or AC operating EV vehicles, and electric vehicles? Like where the DC motors are preferred and the AC motors are preferred in electric vehicles. So which one is more economical to purchase?
I'm not sure I understand your question because.
Okay. So generally, like the DC motors are used to drive the wheels, and even the AC motors. So like when we have a DC motors, I think the cost of the motor and the cost of the other equipments, and in AC motors, the cost of motor and other equipments required. So when we go for this purchasing, which one is more economical?
Again, as I think most of the vehicles have DC motors only. AC motors are not used in vehicles. I'm not entirely sure about that, but from what I have seen is even in my own car and other cars, DC motors are there. I don't think there are AC motors present.
Sir, can I answer this question?
Yeah, definitely. Go on.
Yeah, actually, all the motors used nowadays in India, and two-wheelers and three-wheelers use BLDC motors,
Okay, sir.
and electric cars, Hyundai, Tata, MG, all are using permanent magnet synchronous motors. So all are requiring inverter. So first it takes DC from battery and converts into AC. AC only supplied to the BLDC motor or PMSM motor. So there is no difference. In all the
Okay.
cases, we
Okay.
need a inverter. So the cost will be depending on the power rating and capacity itself, not as DC or AC. All the drives require inverter.
Okay. Okay. Thank you so much, sir.
Excuse me, sir.
Sir, last question.
Sir, I have a question.
See, okay.
Hello? Excuse me, sir.
Yes, please go on.
Sir, good morning. My name is Ravi Kumar. I am from one engineering college. I am a faculty there, sir, in Andhra Pradesh. Actually, just we would like to explore, is there any possibility of collaborating with your industry regarding making of a charging station, sir? Actually, we have made e-bike, we have made e-cycle, and we have also retrofitted e-scooter. But we want to work on charging stations, sir. So, is there any possibility where we can work together, like with your industry, as a part of a student project, or some aspiring entrepreneur or research from faculty? So, is there any collaborative opportunities?
Definitely. I have shared an email address with you in the group chat. Please drop a mail on that and he will handle it further. We have our dealer office in Andhra Pradesh, Visakhapatnam, and they will take care of what you require.
Yeah, thank you so much, sir.
Thank you.
Is there any certification courses related to EV for faculties? So,
Yes, IIT Delhi has
okay.
Yes, IIT Delhi has started a course for in electric vehicles. So that is very useful for faculties. Apart from that, if you're looking at some part-time certifications, there is a company called, just give me a second, I forgot the name. There is a popular company, if you Google it, you'll find them. They are doing very well in terms of training for electric vehicles and electric vehicle chargers. They provide the certifications on Udemy and websites as well. If you go to them and refer to them, they will definitely provide you with a good knowledge and certification.
Okay. Fine, sir. Thank you so much, sir.
Arth Patel, just like if the educational organizations are associating with you, just like what Guru Ismail has asked, like will you be giving any subsidy for them?
So subsidiary is mostly operated.
Has to be given from government, right?
Yes, exactly. Subsidiary is operated by a government. We being a private organization, we cannot give subsidiary, but we usually tie up to set up charging stations at the location of universities for educational and for public usage as well. We recently did it with NIT Warangal. So we have tied up with NIT Warangal where we'll set up a charging station in their premises, which will be used for educational purposes as well as for the public utilizations.
Okay.
Sir,
Another question. Okay, fine. Guru sir, please proceed
sir,
with
excuse me, what is the capital cost of that, sir, to install the charging station or to design the charging station?
The capital cost is anywhere from 2 lakhs up to 12 lakhs.
Range of that voltage is?
Sorry?
Range of the voltage. I mean to say that.
So it starts from having a 7 kilowatt charger and it goes up to having a 60 kilowatt charger.
60 kilowatt. Okay. Thank you, sir. Thanks for your answer.
I think Vivek has asked the question that 2 different AC and DC charging slot given in cars, or is it combined? So it depends on the protocol. As I said, there is a popular system protocol called CCS. Tata Nexon, Hyundai Kona, MG, all are based on the CCS protocol. So CCS is a combined charging system. CCS stands for combined charging system. So in the cars which are based on CCS protocol, such as Nexon, Kona and MG, they have a single slot which can accommodate both AC and DC charging. But for other cars, such as the Mahindra E-Verito or the older Tata Tigor, they were not based on CCS protocol. They were based on some other protocol known as GB/T. So in those protocols, the manufacturer has to give 2 different slots, one for AC charging and the other for DC charging.
Arth Patel, I have another query.
Yes.
Recently, I went to a Samsung phone service. Recently, I went to a Samsung phone service center.
Yes.
So there I had seen, like at the entrance, they had given an option like you can put your old phones or old chargers. We can simply dump it there and they will do some processing for that e-waste. Okay. So now this EV revolution is actually going on. So my query to you is, in another 5 years,
there will be a lot of
there will be a lot of exhausted batteries.
Yes.
The companies or the market players like you have planned to eradicate such sort of battery waste, or are trying to make any provision so that these batteries can be used for a long run.
Okay, so for that, there is a popular concept known as ESS, which is very new in India right now, but in the rest developed parts of the world, it is very popular. ESS stands for Energy Storage Services. So what ESS is basically they use a lithium-ion battery of large capacity to store energy and from solar power or wind or hydropower, and then use it whenever required. So there are some companies who are working, there are some good startups who are working towards making ESS a very common thing in India. So their whole concept lies what you said, that when in 5 years when electric vehicles are very common, there will be a lot of this battery waste generated. So even when the battery is wasted, it might be wasted for the car, but from an ESS perspective, it can be still used to store the energy. So they can take out the batteries, combine them to have a storage system which will be used for energy storage at various locations across the country. So the work has already been done, started in that field, and it has been going on very well.
Okay. Another question to you, Arth Patel. Actually, majority of the questions which I am asking you are the questions of participants. Okay, they are simply posting it in the chat rooms rather than asking you directly. Okay, but the question which I am going to ask you now is my own question. See, you said that you are into this market for the last 4 years.
Yes.
See, what was the driving force for you 4 years back to enter into such a business?
Okay. So for our promoters, the driving force to enter into business was to diversify their business line, as I said, from a mechanical to something else, which can be impacted and can be scaled up very largely. Furthermore, 4 years ago in India, very, very few people were knowing about electric vehicles or electric vehicle chargers. Only after COVID, we are seeing a very large growth in the market.
Exactly.
Even before COVID, very few people were talking about EV or electric vehicle charging or anything. So 4 years ago, you can imagine there were hardly one or two companies in the entire country who were doing the thing which we were doing. So at that time, the vision was very clear that India was a very large market, and under the good leadership, it was growing very fast. It was developing as a country very fast. The purchasing power of Indian population was also growing very fast. So the shift was bound from fuel cars to electric cars. There was no stopping that. Furthermore, the electric technology has no threats. Like as of right now, there are concepts of hydrogen cars and so on, but they are not immediate threats to the electric vehicle as they are only in the prototyping stage. So the market was going to come in 2 to 3 years down the line. It is still very new right now. 2 or 3 years after, it will be very common. So that was one of the driving forces that we had the vision to develop the chargers and then get into this market. Initially, I'll be honest with you, we had the vision to make an electric car. But seeing the competition from large players like Tata, Mahindra, and etc., and the large infrastructure required to set up, the large setup required to make a car was very huge. So that is why we went into the charging line, because we knew that wherever a car would go, there would definitely be a charging station or some sort of charger required. So that was the whole vision behind this, us entering in this industry.
Okay. I wish to ask you one more question. It's like what you have said now, under a good leadership, like we Indians are having a great buying power now, because under the good leadership of the EV manufacturers, we are getting good products and we are having good buying power also. So all this has combined together, which led to a good EV market in India.
Yes.
So my question is, why you haven't gone for? Obviously, you can just give an answer by saying that it's a personal choice. But my question is, why you haven't gone for Tata EV instead of your Hyundai Kone?
Okay, so I basically bought my car 2 years ago. At that time, Tata was not having an electric vehicle in the range, so they only had the Tigor option. And Tigor was very primitive at that time. It didn't have the driving pleasure, it didn't have the functionality. But at that time, only Kona was present. Even MG was not there in the market. So the only option I had to buy was the Hyundai Kone. But right now, a few months back, my father also bought an electric vehicle, and we bought the Tata Nexon car. So Tata Nexon is really good for the pricing, for the features it gives at the pricing. But back 2 years ago, there was no option of owning anything apart from a Hyundai Kone. That is the primary reason we went for the Hyundai car. But if someone asks us what I would buy, every single day I would go for a Tata Nexon. Because firstly, it is priced very well. It comes in the price of 14 to 16 lakhs compared to the MG and Hyundai, which goes way over 20 lakhs. Furthermore, it is an Indian company, and I want to support the Indian company more. And thirdly, the features it gives for the pricing are much better than the other competitive cars.
Sir, one question.
Yes.
Sir, as a startup, if we want to start any charging station at our premises, so for 4-wheeler, 3-wheeler, or 2-wheeler, we have to keep the specifications similar, or it will be different for different vehicles.
So for 2 and 3-wheelers, every company has their own specification. Ather, Hero, Okinawa, they all have their own different protocols for charging, and they all have their own different protocols or specifications, if you say. But what happens is that people carry their charger with their own vehicle in 2 and 3-wheelers. So all you can do is have a charger which has the socket, the industrial socket, and they can plug their own charger which they carry with them and charge their vehicle. For four-wheelers, there are accepted protocols. So all the Nexon, MG, Hyundai, Mercedes, Tesla even are all having a similar connector, and they can all be charged using one charger only. So for four-wheeler, there is a confirmed protocol worldwide which everyone is accepting. But for the two and three-wheeler market, every single company has their own specification.
Okay, sir. And for solar, if you use a solar panels for charging purpose, then there will be different scenario. Means we have to use some another environment or some certification, or
No,
it will be same.
there is no certification on environment required. But for solar charging, what will happen is the investment will go very high, because solar is also not cheap. It is much expensive, is very expensive these days. So if you are getting a solar, will only increase your break-even time, and it will be eventually not very profitable for you.
Okay, sir. Okay, thank you, sir.
Hello, Arth. I want to ask something that you talked about in your presentation. You mentioned that people prefer to have either a 3.3 or 7 kilowatt of charger. Major of the chargers are of this particular range. Okay. So in sync with the topic of the this FDP, are we seeing any power quality effect or any impact on the power grid with these certain kind of charger? Is there any kind of data that you guys keep that certain kind of power quality issues or certain kind of power system issues are there due to such chargers, these low range chargers, or let us say DC chargers, and any kind of data bank that is being monitored by you guys?
So we don't have any sort of that database to provide you an answer with this. But if you ask my personal opinion on this, there is no effect on power grid by having charging stations. Because see, charging station, at the end of the day, charging station is something which consumes electricity. If you have more ACs or more fridge in your society, it will be similar to having a charging station. You just have to give it electricity. There is nothing new happening there. From an electrician or engineer's perspective, there is nothing new happening. The power is the same. If you put a AC and a charging station side by side, they will take the same power if they are of the same capacity. So there is nothing new happening with charging stations. So any power fluctuations or any impact on the power grid is not something which will be faced due to having charging stations.
Okay.
The only impact it will have is that, as I said before as well, in already existing societies and residential colonies, they have some allocated power to them which is being utilized every day. So if they install a new charger or a new charging station in their premises, they will have to ask the DISCOM to increase their connective load. That is the only concern. But any bad impact or any good impact on the power grid due to having charging stations is not there.
Okay. Thank you.
Hope there are no other queries from the participant side.
Someone is asking if putting a 2 or 3-wheeler charging station is profitable business. I think Ashwin Shahu is asking this.
Yeah.
Yes, putting a 2 or 3-wheeler charging station is definitely a profitable business. But to make a charging station profitable right now, as there are not many 2 or 3 or even 4-wheeler cars right now. So what I would suggest is having a tie-up with someone operating 2 or 3-wheeler for their logistics business or anything. There are a lot of companies who are having their deliveries done on electric 2-wheelers or electric 3-wheelers. So having a tie-up with them will ensure that you will get this much amount of utilization. So that will be more profitable for you.
Okay, Arth Patel.
Okay.
It was a very good interactive session.
Okay.
In fact, we came to know more about your company. Tirex chargers. Indeed, it's a great pleasure and a knowledge session for us because we all now know that the Indian market is also standing ahead in the case of EV chargers, EV vehicles, etc. So thanks a lot for sharing such informative sessions with us.
Okay. Thank you so much also everyone for joining and for this opportunity. Looking forward to, if you have any more sessions and any more queries, I'll be happy to answer them as well and join and answer your queries again.
Yeah. On behalf of College of Engineering Talasheri and all the participants of this FDP, I give my wholehearted thanks to you, Arth Patel.
Okay, thank you so much. And also on behalf of the entire Tirex team, I give you a thanks as well for letting us be a part of this session and deliver some information and share and increase everyone's knowledge.
Okay, Arth Patel, bye.
Okay, thank you so much. Bye bye. Take care, everyone. Have a good day.